Welcome to part 2 of your circles review video. Alright, number 5. I'm about halfway through this. I might get done in one more video. Okay, if arc AB is 65 degrees, and AC is congruent to CD. Okay, so those two are congruent. It's kind of hard to mark that on there. I mean, if you have another color like I do, it's one thing, but on your test paper, it's a little bit harder. This guy's perpendicular. That tells me I know this is true. So again, I'm not even looking over here. I'm just looking at what can I do to proceed. That means these are the same. That means this whole thing's 130. It means this whole thing's 130. That means this. Okay, 130 and 130. That's 260. This is 100. What else could I say? I could draw NYC and get some other angle stuff, but I may not need to muddy it up that much. I'll see what I need. Arc AC, done. Arc CD, done. Oh, wow. There was a whole much more stuff I was ready to answer here. Like Arc AD, that would have been a much better question. And so if you have that feeling at the end of the question, if you do, this method I'm suggesting, which is kind of the shotgun method, and you get to the end and you find stuff they didn't ask for, well, then good for you. You're better than the test question. You shouldn't be concerned that they didn't ask you the most interesting thing in the question. It just meant, we were trying to ask an easier question than you were ready for. And that should be a good feeling. That shouldn't be alarming. Yeah, because I know like sometimes in proofs when you did that and you got that feeling like, why did they give me this if I didn't need it? But here we just can't make the test super long, so don't worry about that feeling if that happens here. All right, use trig to find the measure of an arc cut off by a chord 16 centimeters long in a circle of radius 10. All right, I don't want to make it that small. Make it as big as I can. So radius is 10, chord is 16. Well, you know what this is going to look like. It's going to look like this, where that 16 centimeter chord is going to be cut into two chunks of 8 and 8. The radius, this is the best place to draw a radius, is 10. That's my other piece of advice. People who get stuck forget they can draw a radius right there. But they forget that that's the place to draw the radius that's the most help. Find the measure of the arc cut off by a chord 16 meters. Okay, so the question is, what's this in degrees? What is that I'm drawing? I'm trying to draw a little arrow. I'm trying to find the measure. I'll do it this way. Trying to find the measure of this arc in degrees. Okay. That would be great if I could figure out this angle. I drew this 10 in here, and I think this 10 is important to draw here for not only questions where they ask you about this arc, but also when they ask you this length here. That's usually the type of questions we've been focusing on in class, and that's Pythagorean Theorem. If you haven't realized, Pythagorean Theorem is all over this unit, and it's not exactly obvious that it's a Pythagorean Theorem question. Anyway, so I was expecting Pythagorean Theorem. Trig is, same part of the year as Pythagorean Theorem, so we also need right triangles for that. All right, we need to know the angle here, which is the same as the angle down here, which is double this one that's right here in the right triangle. So we'll find that one first. We'll say that the, SOHCAHTOA time, this is opposite, this is hypotenuse, that would be sine, right? The sine of that angle is 8/10. So the inverse sine of that angle is what I really care about. Whoops, not A. The inverse sine of, that's a little 1, of 8/10 is half of this answer, and that is 53.13 degrees. Put that in here. So the arc that we care about is going to be 106. The decimals might round funny. So we'll just go times 2, because those decimals, it might know, 0.1 there, I think I'm okay. Yeah, 0.26. Yeah, it could have been 2.7 if the 3 was rounded down from a 0.4 or something. Anyway, all right, so next one. If AB is 100 centimeters, that's not arc measure, that's length. Well, you know what? I'm just going to write this in so I don't confuse myself later. Because that perpendicular, I can be sure of this. And MC is 10. Wow, that was a bad picture. Find the radius. So I need to find MC. A lot of people are going to look at this and go, oh, I need to find QC. But wait a second. It's a lot easier if I try to find this. Radius, remember, can go anywhere. That part was 50. Okay, then that's hard to see. Let's write that 50 below. I think a little easier. That 50 is down here. you're going, okay, wait a minute, I need to find r. How in the heck do I know this? Well, wait a minute, the radius was 50. Yeah, this is 50, so this little tiny part right here is 40. Bad picture. All right, that's 40, that's 10, because I have to add it to 50. So now I have a right triangle with 40 and 50 and hypotenuse. So that's not bad. 40 squared and 50 squared is r squared. Let's go to the calculator. Plus 50 squared is this. It's the square root of 4100, which is 10 times square root of 41. I kind of like that answer, but you know, it's up to you. Let's write this in here because I'm also gonna publish this as a PDF. So you could, you know what? This is probably easier to think about. Let's just do that. If you really wanted that as a decimal, people really like that sometimes. For 64.03, give you practice in your rounding. Okay, why not? All right, this sounds like another spiderweb question where I should just fill in everything I know. BD's at an amber, that's nice to know. GJB, where's that? Okay, that's 90, it's marked. And AB's a tangent. Okay, well, I really don't know much here. Oh, there's stuff in here marked, great. This is a tangent. AB's a tangent, so don't forget about this little property. That means it's perpendicular to a radius. We don't always get that. There's a lot of problems where they draw a tangent, but there's no radius even involved, so you don't get to use that. This happens a lot on Pythagorean questions in triangle ABF, say. You're trying to find, or even like a triangle ABR usually, you're trying to find Pythagorean length, but rarely does it come up like this. So use that, because we're going to need it. All right, if this arc is 58, what does that help us with? I guess this angle over here would have to be 29. Don't forget about that. What else can we see from this? Is any other, that's a 9. Any other arcs involved in this? I can tell you right now, angle F is going to be a problem because it doesn't have anything to do with arc BG or arc CD because the point F is not at the center. Oh, but look, I have a little right triangle here. Ooh. Right triangle, 29, right angle, this has to be 61. That's cool, but that does not mean that this arc is 61, because this angle F is not at the center. GRB would be the measure of this arc, and I don't have that. I have GFB, which is kind of annoying. If that's 61, this is 61, that might be helpful. But again, arc CD is not 61 because this angle's not the center. At the center, if I pulled that over and connected that, it wouldn't be 61, it would probably be smaller. So be careful of that. This 36 I don't know if helps me with very much because it intercepts as 58, but it's outside the circle. So all the conclusions we've made about how arc measures and angle measures are related, the vertex of the angle either has to be at the center or it has to be on the circle. If it's inside the circle or outside the circle, like at F or at E, we don't have any rules this year that tell us anything about what those angles mean. So, I mean, yeah, how they're related to arcs, I should say. So I know these are 61, but this 61 has really nothing directly to do with the arcs. Oh, look, this 61, though, is an angle in this right triangle. So if this is 61, this has to be 29 in triangle AFB. And another right triangle, AJB, this has to be 61. Oh, now we're getting somewhere. Because this angle, ABE, this is an inscribed angle on this circle. So the arc BH is double. So B to H, let me draw it this way. B to H, that whole thing is double that, 122. Well, you know what? Thank you very much. I could have known that from this 58 because those have to be supplementary. So that's fine. That just tells me I did all that right. That's a good feeling to have. All right, I think I'm kind of out of, I could be wrong, but I think I'm kind of out of things to do. Oh, I guess I even know this angle because of a triangle. I got triangle BDE. That's 29, this is 36. I could do 180 there. I don't think I need it, though. And that math is maybe just too much extra to do. Do we have all this yet? DBA. DBA. Yeah, okay, that was easy. I had that one a long time ago. BGD, BGD, that's 180. It's just a semicircle. And EBD, angle EBD. I had that a long time ago, too. All right, I went way farther than what was asked on this one. Good for me. I don't know about you, but that was really satisfying. Okay. Diameter. Oh, yeah, just label this stuff. Oh, those points are so small. Is this an E over here? That's an M, because I got to label this diameter. Let's pretend that said E. I'm just going to mark this as an E. Maybe your paper's easier to read.
but let's say segment EM for that. Chord, oh, I like GH, and again, that's a segment. GH, you gotta put the right segment notation on there. Right angle other than DNK. DNK, D, where is D? Is that D? N? Oh yeah, DNK would be that one. There's a right angle. If this is a bisector, oh, wait a second, no. Well, there's a right angle EFM. I know that has to be a right angle. This one doesn't really say this is a bisector. I kind of hope it is. Let's say EFM. I know EFM is a right angle because if EM is a diameter, if you connect, maybe we said this before, if you connect a diameter to any other points on the circle, that's going to make a right triangle inscribed in that circle. All right, a tangent, does it say? Oh, it tells me because this is 90, then I know NK is a tangent. And technically tangents are defined as lines, but our book throws them around as segments all the time, so I would take that as a segment or as a line. Radius DF, I think that's an F. I've obliterated the type of that picture. And that's a segment. Inscribed polygon, looks like GHL. Is that a J? I think it is. Secant we didn't do this year. In case you're really concerned, secant would be like JK, and I'm serious. Minor arc, how about HL? Sounds like a triangle congruence postulate. All right, and then major arc, I need 3 letters. But JHL, why not? I know that's bigger than a semicircle. Okay. Some of these. If this is 100 and all these are congruent, well then they're all 100. That's a bad picture. Look at that. I didn't make it. Oh, yeah, okay. That's one. Those are all 100. The whole circle's 60. Whoops. The whole circle, I said it, and I marked it wrong. The whole circle's 360, so that's got to be 60. And that's a central angle. Well, we have to assume that's a central angle. It's the only way to do this problem. In the test, it would tell you better that it's a central angle. This was probably taken from a worksheet where they say something like, assume if it looks like the center, it's the center. But we just have to go with it. All right, if this is 40, B is 80. And I like to write it on there, even though I know it's just for this, because that might help me with something else. Oh, like seeing that to 80 that helps me with A. A then has to be 40, because it also intercepts the same. All right, C has to be 90. What we were just talking about up here. C has to be 90. And D, if this is 65, this arc, like this is a semicircle, right? We're assuming that's the center again. This whole thing is 180, so this is just the rest of 180. That's 70, yeah. Okay, I'm at 12 minutes. Let's try to do a couple more here. All right, this is an inscribed circle on a polygon. E is 100. Those opposite angles are supplementary. If this is 80, then this arc is 160. That's one of those funky inscribed angles at a tangent. They have the same rule as if they were, they have the same rule as if it looked like this. It's half of the arc inside it. Right at a tangent makes the same rule. If this is 160, this is the rest of the circle, so this is 200. It's hard to write really small right there. BD, if this is 12 and this is 1, BD, the way this notation looks, that's just 2 capital letters. That just means that's the distance and a segment from B to D. It's not arc measure, it's not arc length. It's just straight ahead. How far is it from B to D along this chord? Well, if that's 12 and that's 1, how are we going to figure that out? Well, I think we have to assume that we're talking about this kind of situation. Otherwise, this problem's impossible. On the test, we would do a better job of telling you that. All right, don't forget, you can always draw a radius. This is always the best place to draw a radius. And that radius is what? Well, it's got to be the same as this radius, which is 13. Pythagorean triple right here, 12 squared plus x squared equals 13 squared. I remember that one. That's 5. You could do that on the calculator, but that turned out to be 5. But that's not BD. That's just this little chunk right here. So BD is 10. All right, DB, again, we just want the distance from there to there. That's the same as this one down here. You know, those are congruent. That's one of those tangent rules. It's not congruent to OB, but DB and this one down here are congruent. This OB is the hypotenuse of this triangle here with the tangent. So this is 7 because it's a radius. I have 7 squared plus something squared equals 25 squared. 25 is OB. This is another Pythagorean triple. I know that's 24. Okay, and that's the same as DB, so this is 24. Hard to see. All right, I'm going to pause there and pick up in part 3.